Hi, Gershom, Tuanelo, Lutando, welcome. Hi, Lutando, I'm not sure if you wanted to say hello.
Welcome to you.
It's
Welcome,
good to
everyone.
see you guys back.
Welcome, everyone. Where was my questions? So I'm super keen to get to know some of you a bit more. What was your highlights or lowlights of the week? I would love to know. I'll tell you my highlights and lowlights so far as well. You can put it in the chat, or if you're super brave, jump on there with your voice. What's been your highlight or lowlight of the week so far? Okay,
So
while we wait for people to go for it, yeah?
Can I share my highlight?
Please, go ahead, go ahead.
So it stopped raining yesterday, and this morning was the first time I could go out for a walk again with my mom in this beautiful sun. I'm visiting her, and yeah, we're next to the ocean, so we had a little walk in the sun, which was such a highlight. And like you can see, I'm sitting in the sun here as well.
Beautiful. Anybody else got a highlight or a lowlight from the group that they wouldn't mind sharing before I jump in and share mine? So my highlight is just I'm going to go see James Bond, the new James Bond movie on Wednesday, and I got some friends together, and I haven't been to the movies in years, which is so I'm pretty excited about that. So that is my highlight. Okay. Look, while we're doing the do now, please do, if you're willing to share, please share in the chat. I know, like I always find getting to know my students is so helpful. And I know that you may not know me well yet because I'm in internet land, but yeah, just take some time to share a bit about yourself, and I'm sure we'll get to know each other quickly. Okay, so for those who are just ready for maths and nothing else, they just want to get going, the do now question is on the board, and I'm going to hand over to you, Alzan. I don't know if there's anything else you want to say before we get going.
I would just like to welcome everyone again. For those who I haven't said hello to, hello. And yeah, just enjoy today. Peter said that he's only got one board or like laptop that he's working on currently. So that means he might not immediately see your chats that you put in the chat box. So if you guys want to share an answer, please feel free to just unmute yourself. If you want to put on your videos and you want to share just show us how you look, or participate in this classroom with your video, also feel free to do that. And otherwise, if you have any questions, feel free to raise your hand or unmute yourself and ask. That's all from me.
Thanks, Alzan. So just to let you know, I know some of you know that this is recorded. It is recorded, but you're not recorded. So the only person who's recorded is me, as far as I know. Maybe Alzan in terms of her face, but you are not recorded. So you don't need to be worried about that. And yeah, as you feel comfortable, just jump in. Okay, so it's 3 minutes past 5, and if I went back and I set the do now by kind of a little bit of past lessons and a little bit of into. So this is going to be on left-hand side here, question 1, And then this is going to be question number 2, and this is going to be question number 3. And so question 1 requires you to find the coordinates of point A, point B, and point C. Then question 2 also has 3 parts. And then question 3, you have to fill in the missing items. So there's a missing number here, missing number here, a missing here, and here. And so I'm going to give you 2 minutes to try and answer those, because they are kind of at the foundation of where we're going today. And then I will give you the answers. And once you've got them, if you want to share them in the chat, that would be awesome. And yeah, I'm going to give you a little bit of time to get your brains fired. I need to recalibrate my pen for a smaller area. Which number comes first for the ordered pair? Is it the value on the horizontal or the x-axis, or is it the value on the y in line with the y-axis? Which comes first? That's going to be an important thing to think about when you try to answer this question over here. Okay. Well, let me give you the answers for the first one here. So basically, for A's answer, the X value that it is in line with is minus 2.5 or minus 2.5. And the Y value that's in line with is going to be 0. Okay, so minus 2.5 and then 0. For B, it's in line with X is 3 and it's in line with Y is 3. So I'm going to get, the point is going to be 3, 3. And then for C, I'm in line with X is 1 and I'm in line with C is minus 4. So that's the first bit there. Then for the second bit, I'm just going to get a different color quickly. It says basically say whether the following makes sense. 501.3 learners attend a rugby match played by the senior team. So does this make sense? No, because number of learners has to be a discrete amount. It can't occur in fractions. So when we spoke about different types of data, we spoke number of people has to be discrete. Or the distance from school to the nearest shopping mall is 10.75. That makes sense because you can have a fractional small, really, really small amount for measuring distance. And 2004.75 cans of cola, does that make sense? No, because again, this is a discrete variable. You can only have 1 can of cola, 2, 3, 7, 8. You can't have fractional amounts. And then as a preview for today, something called a spider diagram. And what it takes is inputs and gives you outputs. And so 2 times 3 is 6. 6 plus 7 is 13. 8 times 3 is 24. 24 plus 7 is 31. And this last one, we have a choice. You can actually choose whatever input you like. I'm going to choose 5. You may have chosen something different, but 5 times 3 is 15, and out I get 22. Now, what these input-output spider diagrams give you is actually something called a coordinate pair that we spoke about in the previous lesson. And so, for example, the one coordinate pair will be 213. That's that first one. Another coordinate pair would be 831. And then another coordinate pair would be 522. And when I think of coordinate pairs, I think of them as like the mini relationships that we need to understand in the section. And remember, in this section, we're talking about graphs. The graphs are made up of these mini relationships called coordinate pairs. And today, we're going to learn about different types of ways that we can write these mini relationships. Alzana, if I could just ask you, are you hearing me okay? And clearly, I see my internet was being a bit bad. Can you just let me know if you're hearing and seeing okay?
I will. So far, I'm hearing okay and I'm seeing okay.
Fantastic. Okay. So I thought while we're teaching, it's always good to do a little review. So what have we done so far in this 4-unit section? And I thought for people maybe who missed a part of it, a quick little review is good. So the section we're doing is graphs, and that's all about relationships. And the very first lesson was about what we call global graphs and interpreting graphs. And our graphs mainly lived in what we call the first quadrant. So the number lines only had positive numbers. We still had a vertical and horizontal axis, but they lived in this one quadrant called quadrant 1. And what we did is we may have had, I think we had temperature that we were talking about. And when we draw these graphs, there's an important distinction between something called a discrete variable and a continuous variable. A discrete variable can only occur with kind of whole number items. So perhaps what we could say is, as an example, if we have time on the horizontal axis and we have number of people on the vertical axis, then as time goes by, that will be, the amount of people that maybe attend the Zoom today, it might start at a certain time at, maybe like that amount, and then it may go up to here, and it may go up to there, and it may keep going up. And then at some point, later on, it may reach a flat amount, and then it may start going down. Now, this graph is made up of discrete values because the number of people can't be a fraction. The values, for example, let's say this was 2 people, that was 3 people, that was 4 people. The values between 2 and 3 don't really make sense. And so when we draw a graph, you often see that you might see that actually we draw the graph like a straight line, but we actually make it sort of like it's dotted. And so if you see dotted graphs, that's all it means. It just means that not all the points in between are valid. And normally that's a discrete variable that's involved. Now, if, for example, we have something like temperature, which is a continuous variable, then if we had time here and temperature here, we may have a graph that looks, something like that, and it may go up and it may go down and so on. And so these are what we call global graphs because they describe big relationships over some period of time or over some period. Now, within these global graphs are these relationships that I was speaking about. So, and these coordinate pair relationships. So at some point, let's say after 5 minutes, there is a temperature that goes with that 5. It may be 10 degrees, I don't know. Now that little relationship is called a coordinate pair. And every global graph will have lots of these coordinate pairs that make up the whole graph. And so it's good to be aware of just the difference between discrete and continuous variables on the axes, and also sort of curved lines versus jagged lines or straight lines. These are all terms that we spoke about. And then in the last lesson, we spoke about how we can extend from the positive quadrant to what we call the Cartesian plane. And the only difference with this is that this is positive on this side and negative on that side. And we call this the horizontal axis or the x-axis. And then we have another number line, which is going up, and it's positive if it goes up there, and it's negative if it goes there. And this is called the y-axis. And so I'm going to put that label in: y-axis, x-axis. And so if I said to you, where is the point -2, -3? In the old system, we wouldn't have had that. But in this, we can go 2 units in the negative direction. So in line with -2. And then we go down by 3 units 1, let's say 1, 2, 3, and that would be in line with that. And so the point that I wanted to plot, the mini relationship from here, is just this point down here. Okay, so that's a little bit of a recap of the previous lesson. Okay, let me leave that up for a moment. Are there any questions from the class? I'm going to give you a moment to type in or jump on, or anything you'd like to clarify before I move on, because all these ideas kind of work together. Any questions or comments?
Everything's good, sir.
Fantastic. All right, let's rock and roll. So if we go to preview, or if I use my, so I told you earlier on, today is about equivalent forms for representing relationships. And there's a couple of different ways that we can do this. The one is the flow diagram. So I'm going to do one of those. The one is the spider diagram. And then another one is the input-output table. So probably the simplest thing is the flow diagram. So I want you guys to give me an operation like +2, -2, ×3, whatever you like. And then Alzan, you choose one from the chat. So give me an operation. By operation, I mean a plus, minus, times, or divide. So you get to make this up. This is you can help me build this flow diagram.
So we've got to multiply 5.
Okay. So my first operation is going to be multiply by 5. I need a second operation as well. Preferably a plus or minus now.
Let's see. Then a +6.
Okay, awesome. Okay, so this is going to define a relationship. But in order to have this flow diagram, I need what's called an input, or excuse my writing today because I'm on a smaller screen, input and an output. So I would now like an input from the crowd, from the class. What number would you like me to use as my input?
Ooh, we've got an 8 from Camogelo and Gershom.
Perfect. Okay, so the 8 is the input. We're now going to use the, sometimes they call it the function machine. So we go 8 times 5 is 40. 40 plus 6 is 46. So we've got an input of 8 and an output of 46. That's one way of showing an input-output relationship. An equivalent way of showing that is to use the coordinate pair. So that's the same type of idea. Now, and that's not too bad. Now, if I want to turn this into a spider diagram, all I do is I add more inputs and I add more outputs. So let's do this. So I'm going to stick with the times 5 and the plus 6. So times 5 plus 6. But I'd like a few more values from the class. So Ozan, if you could just give me a few more values there.
We've got a 12 from Lutando.
Okay. I'm going to throw in a -2 just because I'm a math teacher and I can do that. What else?
4.
4, okay.
And 7.
Awesome, guys. Awesome, awesome, awesome. I'm loving the variety here. Okay, so in my spider diagram, I need to say 12 times 5. Now, a good thing, guys, is I know my times tables like awesome. I had a really, really good grade 7 teacher who made us compete. And so I know that that is 60. Plus 6, 66. Then -2 times 5 is 10, but it's a negative because of that. So -10 plus 6. Just be careful with the number line. So I'm going to the right, and I should get -4. 4 times 5 is 20. 20 plus 6 is 26. And then 7 times 5 is 35. 35 plus 6 is 41. So now my spider diagram has all of these little mini relationships, okay? And if I wanted to see them in coordinate form, it would be the relationship 12, 66, minus 2 went with minus 4, 4 went with 26, and 7 went with 41. And normally we put them in circular brackets. Oh, but today I'm just... Okay, so the main focus here is there's different ways of writing the same thing. And you know what? There's even one more way of doing it, but this is probably the easiest, which is called the input-output table. Okay, so where have you gone? My pen? Okay, so the input-output table is probably the easiest of all. All it is a thing like this, and you say X and Y. Normally, X represents the input and Y represents the output. That's just sort of a thing from mathematics. And then all we do is we list the pairs that are in these mini relationships. So 12 went with 66, minus 2 went with minus 4, 4 went with 26, and then 7 went with 4. Okay, and so that is the basic idea behind equivalent forms. We have flow diagrams, we have spider diagrams, we have coordinate pairs, and we have input-output tables. And they all basically just show us a little relationship. What they haven't shown us is what we call the global graph, but we'll get to that. Before I move on, are there any more questions, Ozan?
No questions that I can see on the chat so far, Peter.
Okay. So what we're now going to do is I'm going to move into some questions I pulled from the app that Watobe has. So Watobe has some, you can practice these things. Obviously, when you see it from me now, it might feel a bit whoosh. It might feel a bit tough. But if you go back and practice, it gets easier. So this is a question I took straight from the app practicing, and it says, here's the rule. And it's giving us an input-output table, just it's oriented vertically, not horizontally. And I want you to put in, for me, I'm going to call this A, B, and C. I want you to put in the answers for A, B, and C in the chat. And for those people who are watching at home or on the I can't remember the other way that you can watch this. Maybe you can also jump in and let us know what you think. What Y value goes with 0 based on the words that are in that question? I'll give you a moment while I stand up and stretch. Oh. Okay, let's see if I can. There we have some numbers coming in there, looking good. You can sort of see something. Okay, I think that Y is 5 greater than X is just really saying I have to add 5 to whatever X is. So this should be 5, this should be 8, and this should be 14. And that's it. You can see the coordinate pair would be 0, 5, 3, 8, 9, 14. Okay, so that is that one. And I'm going to move on to task number 2. And again, I'm going to ask you now to do this yourself. So this is a spider diagram, but I've left some of the information out. So you need to figure out what, and let me zoom in a little bit so that you can see. You need to figure out what is missing here and what is missing here based on what you've been given about the relationships. This is actually from an old exam, from my old schools. I remember now. So take a moment. We'll call this question number, what should we call this? Question A, and then question B. How would you work this out? How would you know what has to be there?
Pete, I'm wondering if we should maybe ask one of the learners if they want to hop in.
Totally. Alzan, I think we're gonna give, like, the person who jumps in is gonna get serious respect from us. I leave it to you to allocate or see who's, but yeah, I'm super keen to hear some voices from our students.
I wonder, there's two options. The one option is we wait for someone to hop on, or the other option is we choose randomly.
Aha. I think we'll give them 15 seconds for someone to jump on, and then you should choose randomly. You're gonna love it.
Okay, guys. So let's see. And remember, it doesn't mean like you have to get this right. If we don't get it right, at least we tried.
Yeah.
So if anyone's brave enough, we've got Gershom saying A is divide by 4.
A is divide by 4. Anybody agree? Let's see. I think you're onto something, because if I go 11 minus 3, I get 8. But now I still have to somehow get to 2, and then this process has to work for the other one. So let's see if that works. 35 minus 3 is 32, but then 32 divided by 4 is also 8. So that's actually quite hard. So well done. I agree. The answer for this is going to be divided by 4. So we can check this. 11 minus 3 is 8. 8 divided by 4 is 2. 35 minus 3 is 32. 32 divided by 4 is 8. Well done. And then the last one is, what is 43 minus 3, which is 40, divided by 4, and that should be 10. Okay, so these spider diagrams, which are just another way of showing relationships, aren't too bad. Let us
well done to Tandeka and Ayabonga, who gave us the output.
Well done. Yes, well done.
Done to all of you.
Okay, it says here, a rule for creating a pattern is given below. Add 5 to X to get Y. Which ordered pair works for the rule? And this is where I'm going to get the people who are watching on the Watobe website to vote as well. Do you think it's A? Do you think it's B? Or do you think it's C? And so you're going to lock your votes in. We've got a rule in language. We add 5 to X to get Y. Which ordered pair is going to be the mini relationship that matches the rule? I'll give you a little bit of a moment to think about that.
So, Peter, we've got a few learners who's given the same answer here. Okay. Most of them is saying A.
Saying A. I think they're onto this. So I think you've realized that if you add 5 to X to get Y, you have to go from this one, which is X, and add Y, or add 5 and get that one. And so you're quite correct. The answer is A. And here's a sneaky thing. Actually, no, I won't be sneaky yet. I'll save the sneakiness. So we're doing nicely though. Okay. We're going to have another one like this, where we say, this is going to be A, this is going to be B, this is going to be C. And remember, these are all on the app itself, so you can practice this afterwards. and I'm going to let you read it. I'm not even going to read it for you. Which of these coordinate pairs matches that rule? It's a little bit harder, this one.
Okay, Peter, we're getting a few answers again.
Are they the same or are they differing a lot?
They are the same, exactly the same.
What are the answers coming in?
We've got A.
A again.
Most of them.
Okay. So it says multiply x by 2 and then add 10. So if I take 3 and I multiply it by 2, I get 6. And if I add 10 to it, I get 16, which means you are winning, winning, winning. So much winning. Okay. So well done. I think I need to challenge you. I feel like things have got... Okay. So here is a slightly different type of question. It says a table is made using the following 2 patterns. So a table is made using the following 2 patterns. Starting number 8, rule add 4. Pattern Y is starting number 4, rule add 2. I want you to think about how do I fill out the missing spaces here. So essentially, we'll call this one A. Oh, let's make that a bit smaller. Let's make that. So that one's A, B, C, D. And then it also, there's this thing over here, E, which I'm going to leave blank. I want you to try and work out what those are. And then I want you, the E is probably the hardest one. So I'm going to give you a bit of time. And then once you've got your answers, hit A equals, B equals, C equals, D equals, E equals. I'll give you some time for that. Okay, so starting number is 8. If I add 4, I should get 12. Then I should get 16 for that. So those 2. Then C and D start at 4 and add 2. So I'm going to get 6. And then I'm going to get 8. Okay, then the last one, E. The terms in pattern Y are something times the terms in pattern X. So it looks to me, I suppose I should just fill in these values so I can see what the actual thing is. So I've got 12, 16, and I've got 6. It looks to me like they're half. The terms in pattern Y are half or 2 times the 2. No, I need to double what's in Y. The terms in pattern Y are half times the terms in pattern X. The wording's a bit clumsy, but basically what they're trying to say is that, it's, and you can see this, in order to go from X to Y, you have to times by a half. That's all that the question is trying to show you. I'm not going to spend too much time on that because it's a bit clumsy, the wording. Okay, you guys have done really well to the point where I think you're actually ready for a previous type of more sort of exam-like question. So this one we're going to do together. And then the second one, you guys are going to do by yourself. So it says here, it gives you an input number, and then it says times by 3, add 2, and get the output number. So to complete the table, I'm going to say take 1, times it by 3, add 2, and I get 5. Then to fill in the next one, I say 2 times 3 is 6, plus 2 is 8. Then do the next one, 3 times 3 is 9, plus 2 is 11. To do the next one, 4 times 3 is 12 plus 2 is, wait, I made a mistake there. 4 times 3 is 12 plus 2 is 14. Do I really need to carry on doing this manually each time? I think you may have noticed something. What you'll notice is that this is going up in amounts of 3 because of the times 3 here. Now, when I jump from 5 to 10, however, then I need to be a bit careful because I've jumped 5 places, not 1 place. So this will be 10 times 3 is 30 plus 2 is 32. Now it's getting harder. 23 times 3 is 69 plus 2 is 71. 50 times 3 is 150 plus 2 is 152. And then the last one, I'm going to have to use 86 times 3 is, well, 80 times 3 is 240 and 6 times 3 is 18. So 258 plus 2 is 260. Okay, apologies if I went really, really quickly there. But basically, I was just trying to show you how you use the formula to get these mini relationships. What do you notice? What stands out to you about these relationships? And there's no one thing, but if there's one item that you notice from this input-output table, what stands out for you? And I just want to see in the chat, what do you notice? What stands out to you about this relationship here? And if you want to jump in, it might be easier to just jump on and give us a little voice note. Because if you notice this, the next question becomes much easier. Okay, are there any messages?
No messages so far.
Okay.
Anyone that wants to unmute?
Please jump in. I'm going to do this one for you, and then you're going to do the next one completely by yourself. So in this question, it says, describe by means of a formula how to calculate the output number from any input number. Let X represent the input number and Y represent the output number. So if you look at what's going on here, you take your input number and you times it by 3. Okay, you times it by 3, and then you add 2. The reason I know that is that was actually given to me in the question. Now, in algebra, and not everyone, x times 3 can actually be written as 3x plus 2. It means exactly the same thing. And now the only thing I need to do is go, well, what is the output value represented as? And we said the output value is y. Okay. So essentially, all I'm doing is I'm saying it's the input is x. Input is x times by 3, add 2. We know that that's the flow diagram rule. If we clean it up a little bit, in algebra, x times 3 can also be written as 3x. It's equivalent. And then the output is also called y, and we know that from previous examples. So the formula that describes this relationship is just y equals 3x plus 2. Then in English, describe verbally how to calculate the output number for any input. I would just say I multiply input by 3 and then add 2. Okay, and then the last question. What input number will make the statement 3x plus 2 equals 71 true? Oh, this is too good a question for me to steal it. I want you guys to do it for me. I'm going to zoom in because this really does test understanding. So hopefully all you see on the board is a really big D and E. And I want you to type into the chat, what is the answer you get for D? What is the answer you get for E? What input number will make that statement true for D and for E? And I'm going to give you some time, and I'm going to stretch so that my Fitbit doesn't shout at me. If you haven't got the answer, I'm interested to know what you're thinking about. And again, just jump on, like you can literally just unmute your mic and just, have a conversation or just have a little, what are you thinking? What are you thinking about when you try to solve this? I'd love to have a peek inside your head. What are you thinking about right now?
So I think if we look at 3x and then plus 2, it's usually going to, like, if we look at the input value, it's usually going to be 23 because it's usually we first
did you say 23? Did I hear right? 23?
Yes, sir.
So how did you get 23? Because I mean that seems pretty good. What did you think about to help you?
I thought about the input value. So I looked at the input value. So I added the number. So when I added it all together, it came to 71.
Okay.
Yes, sir.
So what you did, I call it a guesstimate. You checked values. You knew that this was going to be somewhere in the 20s. And then when you found the value that you knew, because 23 times 3 gives you 69, which is still too close, or not 71. But when you add 2 to that, you get 71. So you knew the correct answer for this was 23. And I think, is that right? Did you sort of guesstimating?
I was a bit guessing, but when I looked at the input value, it proved to be 23.
Correct. Yeah. No, I mean guessing. I mean, I do this all the time. I call it guesstimating. Like you're estimating and you're guessing at the same time.
Right.
But and the second one, any thoughts on the second one? Because that looks a bit bigger, a bit harder.
Should I answer, sir?
Yeah, if you've got some ideas, that would be awesome. What would did you guesstimate again? What would you start with? What number would you start with?
I think I would start with 86.
86. So I would let's even try 80 times 3. I'm going to start with 80. 80 times 3 is 240. So that's too little. So then you're saying, okay, 86 times 3, which gives me 240, what do I get? 240, 258. Oh, you're getting very close very quickly. Yes, so it works perfectly. So in essence, we're going to get 86. Now, one way of doing it is sort of just guessing and then getting closer and closer. The other way of doing this is to use equations. Now, I'm not going to do this now because it's a separate unit. But if you learn how to solve equations, what you could have done, I'll just make a little note about it. How many of you have done equations this year already? Just give a thumbs up if you've done equations. Give a thumbs down if you haven't done equations. I'm just curious to know for my own teaching going forward. So if you've done the unit on equations.
Yes, sir.
Yes, you've done it?
Yes, sir. I've done it term 3.
Perfect. Okay, so if you've got the power of equations on your side, what you could do is when you solve an equation and you solve for the variable, what you do is you make sure you do the same thing to both sides. And if I take away 2 from both sides in this equation that let me zoom in for a second just so everyone can see exactly what I'm doing. If you take away 2 from both sides, I think most of you would agree that I get 3x is 69. And then if I use the opposite of timesing by 3, and I divide this side by 3, and I divide this side by 3, what you'll notice is that those cancel out, and you get the answer of x is 23, which is exactly the answer that we got up here using guesstimation. So just remember that if you've learned about equations, you can use the equations methods. If you are feeling a bit like, oh, I don't know what's going on with equations, that's fine. Look it up on Watobe. I'm sure that there is an equations unit that you can use to practice, but you don't have to have it for this section. Okay, thank you so much for jumping in there. It was so lovely to hear some of who's on the other side there. Okay, let me move on a little bit. I was going to do another question. Give me a second while I look for, should I move on? Okay, let's do this question because I think I like to do a variety of questions. On the board now, you have two choices. You're either going to choose A or B, and you also have to figure out what the missing values here are. So it says, the following rule describes the relationship between X and Y. To find the Y, multiply X by 4 and then subtract 3. And then it says, from these many relationships, choose the correct graph. So basically, this question is asking you, you have to match the rule to the correct graph. So I'm going to give you some time. And when you've chosen your graph, please put it into the chat stream. And for those of you on the live watching on the Watobe website, you can vote with the AB thing buttons. Let's see what you guys think. Notice how this is a global graph now. It's not just like a little thing. It's lots of points connected together. Okay, we've got about 15 minutes left. Alzan, are there any answers coming in there?
No answers yet, Peter.
Cool. No, I think I must just slow down and they can take some time to consolidate.
Cool. I'll let you know if there's anything.
Great. So the points that I have are the points 1, 1, the points 2, 5, and the points 3, 9. Now, which of those two graphs have those points on them? How would we check? Where is the point 1, 1? It feels like both of them have the point 1, 1 on them. Oh. So 1, 1 is on both of them. So that doesn't help. Which one has 2, 5? There's 2. Oh, 2, 5 is not on this graph. Whereas 2, 5 is on this graph. So there are the two mini relationships. Whereas here, it doesn't fit. And then let's check the last one, 3, 9. So 3 across. Okay, which one do you think it is now, based on what you've seen?
So the answers that we have is, yes, B first.
Fantastic. Okay. This is going to be the last question of the day. And it is, in fact, you know what? Let's leave this for the next lesson. We're not going to finish with this because this is actually an old exam question. I'm going to start the next lesson with this question. And I think what we're going to do is we are going to call it a day. I do have a little fun quiz that we could play, but it depends on time. And Alzan, what do you think? How are we doing for time?
I think we can definitely give it a go.
Okay, so guys, when I'm in the classroom, kids love this game. However, I'm not sure if basically I want to show you the leaderboard while we're doing it. I'm not sure if it's going to work perfectly. So if it doesn't work perfectly, then all you do is you do this quiz after the lesson by yourself. But I'd love to try and play it live just for fun. So what I want you to do is I'm going to open up my quizzes, and I'm going to start it live. In fact, hold on for a second. Let me try and, oh, no, it's not working. Okay. I tell you what, we're not going to be able to do live today, but can you please go into this quiz and attempt this quiz for just 5 minutes? So if you don't finish in 5 minutes, you come back in 5 minutes and we're going to say goodbye to each other. But I just want you to take 5 minutes to try and do this quiz. And the way you do it is you go joinmyquiz.com and then you type in that code, and then you should get funky music and there should be pictures. And I want everyone to give it a go and then come back and tell me what it felt like doing the quiz. Okay. I've always been a fan of trying new things in the class. And just, who knows? Maybe this is for someone, it's like, oh my gosh, I found the perfect way to practice my learning. So let's give it a bash. And we've worked hard today. That's why I think it's time to wrap it up. I'm not going to push any further. And just give us a thumbs up if you've got in, or it seems to be working. You might have to open up another tab or another browser or Is it working, Lunico?
So should I try it in?
Let's try it now.
Google? Should I try it in Google or in
the search at the top? There's like a the browser. You type in joinmyquiz.com, and then it asks you for a code, and you put the code 482311102.
Oh, okay, sir.
Just see if you can get it to work. And even if it doesn't, you don't have to finish it now. Okay, cool. Oh, no, it is working. So we may not all be able to do it now. I'm just trying to see that you can get in. And give it 2 or 3 minutes, and then we'll come back and report about it and see what we think of it. Okay. When I teach in the class, we often do these quizzes on a Friday after lunch. You know those lessons when everyone's tired and you just need to reflect? For me, it says invalid game code. I think it's, just check you haven't typed it wrong maybe. The 48231102. So there's only like, or 48, 23, 11, 02. Okay, so Alzan, we'll give it about another minute and then we will call everyone back, I think, just to finish off. But it's a worthwhile exercise just to, yeah, see if we can get this going and working. I think so.
Sure thing, Peter. No problem.
I think I can actually even see on my side who is doing what. Although I think I'm in the wrong profile on Chrome. So that is the problem. Let's see. Reports. Oh yeah, I can see 10 people in the quiz. Yeah, it's working. Okay, Alzan, thank you so much for your flexibility. I'm going to hand back to you. And the students who haven't finished now, the good news about this is it's there for a long time, and I can actually pass on the people who've been doing it for your leaderboard next time. And so we can even add that. But I think we all deserve a hand clap. We worked really hard today. And I feel like you guys, yeah, I feel like you really got a decent chunk of understanding going that will serve you well going forward. And don't forget, we have our final lesson of the series on Thursday. No, not Thursday, Wednesday, where we'll talk more about how to plot graphs and bring all these bits and pieces together. So thanks so much, guys. I've really enjoyed today. It's been lovely having the participation. And thanks, Alzan, for being there and helping me along the way.
Awesome, Peter. Thanks to you. And before I say goodbye to the learners, I just quickly want to show you where you can go if you want to revise on Watobe. So it's fine if I share my screen. Yes.
Yeah, all yours.
That would be perfect. Thank you.
Cool.
So basically, let me just find the right one here. There we go. So guys, like Peter said, this is our second last lesson. You can see this horse still running, going strong, and I feel that's you guys today. So well done for keeping up. And to see where you guys are at next week Thursday. Next week Thursday. This week Wednesday. Yes. We'll have your names up here. Like Peter said, we'll check out the quiz as well to see how many lessons you've been doing. And then you'll get a massive applause from all of us. So be sure to go and practice. And then where can you go to practice? You go onto the Watobe app, into graphs. And then there's 2 lessons that you guys can do for Wednesday. The first one is draw a table from a graph. And the second one is a graph sequence relationship. Okay, so that's all from our side. Thank you so much, guys, for joining in again, for participating. And we wish you well until we see you again on Wednesday. Take care.
Ciao. Okay.
Bye, sir. Bye, ma'am.
Cheers.
Bye-bye.
Bye, sir.
Bye, guys.